Welcome back to another deep dive. So think about the last time you asked a massive AI model a really specific question. It types up this beautifully structured, incredibly confident response.
Yeah, complete with bullet points and everything.
Exactly. Bullet points, a nice concluding summary, the works. And then you realize it just made the whole thing up. I mean, it confidently lied right to your face.
Right. It hallucinates because the model is basically doing its absolute best to predict the next plausible word based on a really vast but, entirely static memory.
And that static memory, that is exactly the crux of our mission today. We're unpacking a massive stack of technical papers, cloud architecture guides, industry notes, all to understand the ultimate fix for AI hallucinations. We are diving deep into RAG.
Yes, R.
And for this deep dive, I'll be playing the role of the curious investigator for you, the listener, while we have a resident AI system architect here to guide us through all the technical weeds.
I am ready. We are going to map out how we essentially force the AI to look up the facts before it opens its mouth.
Okay, let's unpack this. Looking at the architecture guides, RAG, which stands for Retrieval Augmented Generation, it essentially splits the AI's job right down the middle, right?
Exactly.
Like one system physically digs up the data, and the language model just tells the story based on what was found.
Right. If we break down the acronym, the mechanical sequence is right there in the name. So first, you have retrieval. That is the system querying an external database to pull highly relevant documents.
Okay.
Second is augmentation. That is taking those freshly retrieved documents and injecting them directly into the context window, basically appending them to the user's prompt.
Right, stuffing them in there.
Yeah, exactly. And then finally, generation. The language model reads that augmented prompt and synthesizes an answer, but restricted solely to that newly provided context.
So using a standard language model without RAG is, well, it's kind of like taking a closed book exam.
Oh, that's a good way to put it.
Yeah, you sit down, you stare at the test, and you just have to rely entirely on whatever you memorized months or even years ago.
Right.
But RAG turns it into an open book exam.
Right.
You read the question, flip through a customized textbook to find the specific paragraph,
Yeah.
and then formulate your answer based on the actual text right in front of you.
And that open book approach is completely necessary because large language models, despite their brilliance, they are closed ecosystems.
What do you mean by closed ecosystems?
Well, the knowledge inside a standard model is parametric. It is mathematically baked into the weights of the neural network during its training phase. And once that training phase ends, the model's worldview is permanently frozen in time.
Frozen. So if I ask a frozen model about, say, today's closing stock price for a tech company, it doesn't actually know.
Not at all.
It might just give me a highly detailed breakdown of the 2008 financial crisis instead, just because that's the strongest historical context it associates with the words market and crash.
Exactly. Without real-time data, the model simply strings together plausible-sounding words from its training distribution. It is an incredibly powerful reasoning engine.
Right.
It understands language, logic, structure, and tone better than almost any software we've ever built. But it is fundamentally not a database.
I know some of you listening are probably wondering, if we are building these models with trillions of parameters, why not just bake all the knowledge directly into the network? Like, why separate the reasoning from the knowledge?
Because expecting a neural network to memorize every single changing fact on Earth is wildly inefficient.
Oh, for sure.
Think of the compute cost alone. Updating a model's parametric memory requires retraining, which takes massive clusters of GPUs running for weeks.
Yeah, you don't want to do that every time a stock price changes.
Exactly. RAG bridges the gap by letting the LLM act purely as the reasoning engine. It dynamically fetches external facts from a separate database that can be updated continuously without ever having to touch the massive model itself.
Okay, so let's get into the mechanics of that dynamic fetching.
Yeah.
Starting with the R, retrieval. The engineering notes are very clear that this isn't just a basic Google keyword search.
Yeah, definitely not.
Where you just type in like vacation policy and look for a document containing those exact words.
Right, because relying solely on keyword matching is terribly fragile for an automated system. If your company's HR document uses the phrase paid time off, a rigid keyword search for the word vacation just misses the document entirely.
Oh, right, because the exact word isn't there.
Exactly. So RJOS solves this by relying heavily on embeddings. We take your entire database of text, all your company PDFs, manuals, articles, and run it through a specialized embedding model that converts the text into high-dimensional vectors.
When you say high-dimensional vectors, that sounds very abstract.
Yeah.
But you aren't just assigning it a random barcode.
No, not at all.
You are mapping it into a high-dimensional geometric space where physical distance literally equals semantic similarity.
Yeah.
Like, the model learns that the vector for king minus man plus woman geometrically lands you right next to the coordinate for queen. That is how semantic search actually catches meaning, not just letters.
Right. In a vector space with thousands of dimensions, concepts with similar meanings cluster together physically. So when you ask a question, the system converts your query into a vector as well and performs a semantic search to find the text vectors that are geographically closest to your query's vector.
It understands the underlying intent.
It does. It gets the context.
Okay, but semantic search is great for, well, vibes. Like if I search for quarterly profits, the vector space knows to look for Q3 revenue even if the words don't match.
Yeah.
But wait, what if I'm searching for a highly specific product serial number?
Like a part number.
Yeah, like AX99. That string of characters doesn't have a vibe or a synonym. Semantic search might actually fail there because AX99 doesn't carry conceptual meaning in the same way the word profit does.
And that vulnerability is exactly why enterprise architectures, like the ones deployed on Google Cloud's Vertex AI, they utilize hybrid search.
Hybrid search, so blending them.
Exactly. They don't rely purely on vectors. You run the semantic vector search to catch the concepts, the nuances, and the synonyms. But simultaneously, you layer a traditional keyword search on top of it.
To catch the exact serial numbers.
Right, the exact serial numbers, acronyms, or specific corporate jargon. And then a re-ranking algorithm looks at the combined results from both methods, scores them mathematically, and decides which pieces of text are genuinely the most relevant to the user's query.
So it's like a super librarian using hybrid search to gather the absolute best documents. Now we move to generation. We hand this bundle of documents, along with the original question, to the LLM.
Right, and we wrap it in a very strict system prompt. We instruct the model, you are an expert assistant. Answer the user's question using only the provided source material.
Only the source material.
Yes. And we add, if the answer is not in the source material, explicitly state that you do not know.
Which highlights a massive vulnerability in the system. Because an open book exam is only as good as the textbook you bring into the room. If the retrieval step grabs the wrong information, say the hybrid search pulls a document full of outdated policies from 2019, the AI is going to confidently generate a completely wrong but highly sourced answer.
Garbage in, garbage out. The LLM in the generation phase is highly obedient. If you feed it garbage context, it will generate garbage output, and it'll format it with perfect grammar and structural precision.
That's the scary part.
Yeah. The entire system's reliability hinges entirely on the quality of the retrieval phase.
So let's trace the actual data flow so you listening can visualize building one of these systems. Looking at the LangChain framework documentation, there's a distinct 5-step pipeline.
Right.
Step 1 is simply the user asking a question. Step 2 happens behind the scenes, loading and chunking the data. Because we can't just feed a 500-page PDF into the AI at once due to context window limits.
Now, every model has a maximum threshold for how much text it can hold in its working memory at one time. To respect that limit, we have to slice the massive documents into smaller, manageable chunks, perhaps 1,000 characters each.
But chunking a document isn't as simple as just cutting the text blindly at the 1,000-character mark, right?
Not at all.
Like, if you are parsing a complex financial PDF, a naive chunking tool might rip a markdown data table completely in half. It could separate the column headers from the actual financial figures.
And then the LLM just gets a chunk of floating numbers and has zero idea what they represent.
Right.
Honestly, document parsing is arguably the hardest part of production already. You need intelligent chunking strategies that respect the inherent structure of the document. So keeping tables intact, keeping logical paragraphs together.
That makes sense.
We also implement chunk overlap.
Oh, what's that?
So if chunk A ends with the CEO of the company is, and chunk B starts with Jane Doe, who took over in 2022. If you split them rigidly there, the AI never connects Jane Doe to the CEO title.
Oh, because they're in different chunks.
Right. So an overlap of, say, 200 characters ensures the complete context exists cleanly in at least one chunk.
Okay, so step 3. Those intelligently structured chunks are converted into embeddings and stored in the vector database. Step 4. The user's query is embedded, and we perform our hybrid search to retrieve what the documentation calls the top chunks.
Right. You purposefully limit it to the top 5 or 10 most relevant chunks to avoid overflowing that context window limit we talked about.
And then comes step 5. Those top chunks are injected into the prompt, and the LLM generates the localized answer based solely on those specific paragraphs.
Exactly.
The three cobblers metaphor helps visualize this pipeline beautifully. You basically have a dedicated team working in the background for you.
Oh, I like this analogy.
Yeah, first, the researcher, that's the retriever digging into the database stacks. Second, the editor, that's the chunking and re-ranking system organizing the raw paragraphs so they actually make sense.
Right.
And finally, the speaker, the LLM, taking the editor's curated notes and delivering the polished answer to the user.
Visualizing those distinct roles really explains why enterprises are adopting RGRAG so aggressively. It dramatically reduces hallucinations because the speaker is tightly constrained to the editor's notes.
It has a script.
Exactly. And it allows for instant, real-time knowledge updates without ever touching the model. If a policy changes, you just swap out the PDF in the vector database, and the very next query pulls the new information.
It also solves the corporate data privacy nightmare, doesn't it?
Oh, completely.
Like a bank can point a RAG system at highly proprietary financial records or legal contracts. The AI reasons over them dynamically to answer employee questions, but that sensitive data never leaks into the public training weights of a global model. It stays securely within the enterprise perimeter.
It's a huge selling point.
But, and here's where it gets really interesting, if RGRAG is this secure hallucination-killing powerhouse, why do so many internal corporate bots still give terrible answers? I mean, the document parsing failures we discussed are one piece of the puzzle, but these academic papers highlight a deeply fascinating vulnerability called the lost in the middle problem.
Yes. That paper was eye-opening. Researchers discovered a severe degradation in how LLMs process injected context. When you feed a model a very long prompt, let's say you successfully retrieved and injected 15 chunks of text, the model pays incredibly close attention to the very beginning of the prompt and the very end.
But the middle.
Its attention mechanism just fails in the center. It simply ignores or forgets the crucial information buried right in the middle of the retrieved text.
That is staggering. If the exact fact you need happens to be in chunk number 8 out of 15, the AI might skim right past it and confidently declare the provided context does not contain the answer.
Yep, happens all the time.
So if naive Ray is just blindly fetching 15 chunks of data and hoping the LLM reads them properly, I assume the industry is building systems that introduce some sort of active filtering step, like having the AI evaluate the documents before it attempts to use them.
Exactly. We call that modular RAG, or more specifically self-RAG. Instead of a blind automated pipeline, we actually give the LLM agency over its own research.
The agency over its research, okay.
Yeah, so it evaluates the user's prompt first. It outputs special reflection tokens. If you just type hello, it generates a token stating no retrieval needed and simply replies hi without ever querying the database.
Oh, wow. It actively decides not to search to save time and compute.
Exactly. And when it does search for a complex query, it evaluates the individual chunks the retriever brings back. It might look at chunk number 8, realize it is completely irrelevant to the specific nuance of the user's question, and output an irrelevant token.
And just throws it away.
Right, discarding it before generating the final answer. The LLM essentially manages and edits its own research process to keep the context window perfectly clean.
Which perfectly anticipates a massive architectural question for anyone implementing AI. If an enterprise is going through all this trouble to build an intelligent research agent, chunking PDFs, managing vector databases, setting up self-RAG, just so the AI knows the new employee handbook.
Right. It's a lot of work.
Why not just change the model's brain? Like, why not fine-tune the model on the handbook so it simply knows the information and doesn't have to constantly search a database in the first place?
That debate. RHAV versus fine-tuning. That really comes down to understanding the quadrant of AI adaptation. Fine-tuning involves mathematically updating the neural weights of the model by training it on thousands of highly curated examples.
So you're literally rewiring it.
Yes, you are fundamentally altering its internal structure and consuming massive amounts of GPU compute to do so.
So you'd use fine-tuning when you want to permanently change its core behavior or style. Like, if a hospital wants the AI to inherently output medical summaries in a highly specific XML format or understand the syntactic structure of dense clinical jargon, you fine-tune it to learn that new language behavior.
You teach it how to speak, not what to say. Fine-tuning is a highly expensive, really inefficient way to teach an AI changing facts.
Okay, I see.
Like, if you fine-tune a model to memorize that John Smith is the CEO, and then John Smith leaves the company next month, your model's neural weights are instantly outdated.
And you'd have to spend thousands of dollars on compute to do brain surgery on the model all over again just to update the CEO's name.
Right, whereas with RAG, you just delete John Smith's name from the text file in the database, and the external search immediately picks up the new reality.
So our RAG provides cheap external factual grounding,
Mm.
while fine-tuning provides deep internal behavioral adaptation.
Exactly. And the cutting-edge frontier is actually combining them. Yeah, fine-tuning a smaller model so it perfectly understands the complex linguistic jargon of your specific industry, and then plugging that specialized model into a RGAG pipeline to fetch the daily changing fact.
And we're seeing that dual architecture roll out everywhere. The industry notes highlight massive open source frameworks that are just dominating this space.
Oh yeah, huge framework.
Tools like Retrieval are built specifically to solve that document parsing nightmare we mentioned earlier.
Right, cleanly extracting data from complex financial tables without losing the rows and columns.
Exactly. And then you have frameworks like Diffy, allowing developers to visually map out these intricate modular RGREG workflows with drag-and-drop logic gates.
The ecosystem has moved so far beyond just calling an API and typing a prompt. Implementing AI at the enterprise level means building an intricate, highly resilient data pipeline around the LLM.
So what does this all mean for you listening? Especially if you are looking to transition your career into the AI space. The golden rule emerging from all these technical papers is super clear. Do not limit yourself to learning how to write clever prompts.
Definitely not. Prompt engineering is rapidly becoming a baseline commodity.
So what should they learn?
If you want to be truly valuable, you must understand data flow. You need to understand how vector embeddings map high-dimensional relationships.
Right.
You need to know how to design intelligent chunking strategies that respect document structure and how to rigorously evaluate retrieval metrics like hit rate and semantic relevance.
Making ARG work efficiently is infinitely more valuable right now than just tweaking a system prompt. Because at the end of the day, building useful AI isn't really a model problem anymore.
No, the reasoning engines are smart enough.
Right, it is entirely a data problem. The entire challenge is getting the exact right piece of context in front of the model at the exact right millisecond.
And looking at how rapidly these systems are scaling, it actually raises a fascinating new dilemma for the enterprise space.
Oh, what's that?
Well, if every company deploys R to dynamically fetch real-time data, and those AIs are constantly generating summaries of internal reports, white papers, and emails,
Yeah.
what happens when one R system retrieves a document that was actually generated by another R system?
Oh, wow. If an AI is treating an AI-generated summary as a foundational ground truth document and then generating a new summary from it,
You risk creating a closed-loop echo chamber. The AI isn't retrieving human knowledge anymore. It's retrieving its own synthetic exhaust.
synthetic exhaust.
Yeah, and as we build better automated retrieval pipelines, we really have to ensure our systems aren't just continuously checking out each other's hallucinations and treating them as facts.
An automated feedback loop of corporate hallucinations. That it's definitely a thought to chew on as you look at your own company's data and AI integrations. Well, thank you for joining us on this deep dive into our RAG. I hope this armed you with a solid grasp on how we actually ground AI in reality.
It's been great exploring this.
But the rabbit hole goes much, much deeper. Make sure you join us for our next deep dive into a new stack of notes, a deep understanding of text, image, and voice.
Oh, that's going to be a fun one.
It really is. We're going to explore the wild frontier of multimodal models, when the AI stops just reading text and starts seeing and hearing the physical world around it. You definitely won't want to miss it. Remember to subscribe to the channel, and until next time, tschüss.